Okay, so now we are going to look at all the possible solutions for our equations. All right, up to this point, we get things like x equals -1, x equals 5, whatever. But that's not always the case. So we're going to explore a few things, okay? So a couple of definitions, right? We have one solution, which should be familiar, and that is when one variable equals one value and only one value. So x equals 3 is an example of one solution. Okay? Next option is no solution. Okay? No solution. Now you can probably guess, no solution is when it's impossible for the equation to be true as it's written. Okay? So, and I'll give you some examples here in a second. But basically the answer that you get is impossible. That is no solution. And no solution is a valid solution type. Yeah? The third option for us is going to be infinite solutions. All right? And infinite solutions is when you plug in any value for the variable would make the equation true. Okay? Any value for the variable, any value for x, makes the equation true. That is what we call an infinite solution. Okay? So here's 3 examples. And we are going to solve them and identify what solution type they are. Let's look at the first one. X plus 3 equals x plus 3. Well, if you have your notes handy with your patented Finnegan algebraic algorithm, we want to, we can do a few things. We can move all the variables to the left side, or we can move all the constants to the right side. So if I subtract x, I'm subtracting because it's the inverse or the opposite of positive x. I need to make it a minus x or a negative x. That'll cancel those out. Subtract x from both sides. Again, I'm combining these like terms. I can't subtract x from 3 because those aren't the same. I can subtract x from x though. And what do I get? Oh wait, those cancel too. So I'm left with 3 equals 3. So anytime you get a constant equaling itself, like this, 3 equals 3, this is a huge red flag, not a red flag, but this is a huge indicator that we are looking at an infinite solution. Why is it infinite? Infinite solution. Why is it infinite? Because I could put in any value for x and I would still get the same solution, right? So if I put in 10 for x, 10 plus 3 equals 10 plus 3, 13 equals 13, yes, that's always going to be true. All right? That's an infinite solution. So if I were to subtract 3 from both sides, then I would get x equals x. Again, x equals x, infinite solution. Any value of x is going to equal that same value when you plug it in on both sides. Yeah? Infinite solution. Okay, cool. X plus 1 equals x plus 2. Well, let's move the variables around. Subtract x from both sides. That cancels. And those cancel. What am I left with? 1 equals 2. What do we think? Is that true? It's never ever going to be true. So that is a no solution. Right? The variables canceled out. The constants are not the same. Therefore, it's a no solution. Okay? There's no value that I could plug in for x to make this equation true. If I plug in 10, 10 plus 1 is 11, 10 plus 2 is 12, 11 never equals 12. No value. Impossible for this equation to be true. No matter what value I put in. No solution. Okay, x plus 7 equals 4. My algorithm, I want to move all the constants to the right. My tools are addition and subtraction. I see that 7 on the left side. I need to move it to the right. How do I do that? I do the inverse operation. The opposite of positive 7 is negative 7. The opposite of addition is subtraction, right? If I do it to one side, I have to do it to both sides. I can combine these because they are both constants. They are both like terms. That gives me x equals 4 minus 7, negative 3. Box it up. I can box all these. Okay? X equals 3. One variable has exactly one value. One variable has exactly one value. It equals one value. So this, of course, is one solution. All right, those are our 3 solution types. Thanks for watching.